Welcome to the boring math video. For this section, it's boring because this video is so easy compared to the other ones. All right, so I hope you're ready for something easy. You know, lay back a little bit, relax, wear some really casual clothes, whatever you need to. We're going to talk about domain and range. So domain and range are all the inputs and all the outputs. But remember, any parabola you can possibly draw, any parabola going up, going down, skinny, not so skinny, any parabola, the domain, all of the x values are all real numbers. Any parabola, if I ask you, what's the domain of this parabola? You got the same answer every time. And the range, there's only a little bit that goes into the range. Okay? The domain of any quadratic, any parabola, is all real numbers. Negative infinity to positive infinity. Right? These are the same thing. The range is a little different, right? If I look at a parabola, maybe the parabola goes up, maybe the parabola goes down. Well, if there's a minimum, the range is just that minimum up to infinity. If there's a maximum, then the range is just negative infinity up to that maximum. But either way, that maximum value is at the vertex. Okay? So range is either negative infinity up to the maximum or the minimum up to positive infinity. But either way, right, this is going to be for if it's opening down, and this is going to be if it's opening up. And the k is the y-coordinate of the vertex. So as long as we know the vertex, we can find the range no problem. Let's do some examples. Example 6. Find the domain. Oh, there's a small error here. The vertex is included here. Okay, so in this domain, in this range rather, here, let's just make, I don't know why my eraser is so big. Let's use a smaller eraser. I don't know if that was any smaller. K is included. All right, so it should be a bracket. Find the domain and range for the following quadratics. F of x equals negative 2 times x plus 2 squared plus 3. Well, right off the bat, I know the domain. I'm done. Domain's all real numbers because it's a quadratic function. We can plug in anything we want into this function. It's not going to cause a problem. Remember, some of the problems when it came to domain and range were dividing by 0, taking the square roots of negatives. Those are the big ones. But we have no division. We have no square roots here. So domain's going to be all real numbers. So for the range, we just have to know two things. What is the value of A? And what's the vertex? Well, A is negative. Right? A equals negative 2. So that means it opens down here. There's going to be a maximum. So the smallest we can go is negative infinity. The biggest we can go is K. What's our K value here? Oh, it's right there. We're already in vertex form. Boom. We're done. This equation has all real numbers as the inputs and everything up to 3 as the outputs. And let's look at that. Maybe you don't trust me. Well, this is going to be negative 2 times x plus 2, 8, plus 3. Domain and range. Domain is all the inputs. Yep, we can go as far to the left as we want. We can go as far to the right as we want. For range, we can go as far down as we want. But the biggest we can do, the biggest y value we can ever hit is positive 3. Let's do another one, part B. Find the domain and range of this function. 3x squared plus 2x plus 1 Well, again, it's a quadratic function. The domain has to be all real numbers. The range, well, let's look at A. The A value here is +3, so it opens up. So the range is whatever the y coordinate is of the vertex, and then we can get as big as we want. The difficulty here is that we don't know the y coordinate of the vertex this time. It's not 1. That's not the y coordinate. We're not in vertex form. So we need to find the vertex. So it can get a little bit more involved, but this is as bad as it gets in this video. The axis of symmetry is useful for finding the vertex. That's at -b over 2a. That's -2 over 2 times 3. The 2's cancel. That's a -1/3. Well, the y value at the vertex is just the function value on the axis of symmetry. The function value at this axis of symmetry is going to be 3 times -1/3 squared plus 2 times -1/3 plus 1. All right, let's try it. -1/3 squared is 1/9. 3 times a ninth is 1/3. 1/3 minus 2/3 is -1/3. -1/3 plus 1 is +2/3. So the smallest this function should ever get is 2/3, and the biggest it should get is infinity. Let's check our answer. We graph this. We get +3 x squared plus 2x plus 1. The smallest we get is 2/3, and the biggest we get is +infinity. We did it. That's our domain and range. That's the video. Let me know if you have any questions, and good luck.